This is Rivet. I had an acting role in the 2005 movie remake.
Good morning. My name is LaShonda, and I will be your conference operator today. At this time, I would like to welcome everyone to the APM Community Webcast Smart Instrumentation. All lines have been placed on mute to prevent any background noise. After the speaker's remarks, there will be a question and answer session. If you would like to ask a question during this time, simply press star, then the number 1 on your telephone keypad. If you would like to withdraw your question, press the pound key. Thank you. I will now turn today's call over to Mr. Andreas Rice, Principal Engineering Services Architect. Please go ahead, sir.
Great. Thank you very much for the introduction, and hello to the APM community. Today is our session about smart instrumentation and entry point detection. In this session, the agenda for today, first we will talk about why smart instrumentation, why entry point detection, and why these topics are related. The functionality, the visualizations on these features, configuration and artifacts, and we can discuss some use cases, how to best work with smart instrumentation and automated front-end detection. And of course, in the end, all your questions you post on the QA section. So why smart instrumentation? In our out-of-the-box Java agent, we provide visibility for the most important components inside the agent. What means most components, most important components? Typically, we focus on all boundaries of an application, incoming requests, like, for example, HTTP request, like a servlet request, or messaging request. And additionally, the boundaries, outgoing calls to external systems, to web services, databases. In the middle, we have additional important metrics we cover, like, for example, AGBs, special frameworks like Spring, Struts, or on specific engines. These monitoring points is what we identified as the most important monitoring points to get perfect visibility inside your application. But sometimes it's necessary to go beyond these most important components to identify what happened inside different transactions, what happened in between controller components and a call, for example, to an external web service. So looking into these two features, smart instrumentation and front-end detection, it's more than only deep transaction traces with multiple components. What we want here is to extend the visibility in your application, and in this session I will also cover how you can take this information and provide additional visibility by configuration with new discovered components. You can identify application problems, differences in call paths, and understand sources for errors, understand sources for problems, for stalled transactions. So these two features work hand in hand on our agent technology. They both rely on dynamic instrumentation, a feature which allows us to instrument Java applications on the fly, and they leverage this functionality. Before we go into the technical details, I'd like to explain to you the evolution on transaction analysis, what we do inside the agent. And here's a short overview of the evolution from Introscope 9.6, the inner circle, to 9.7, to APM 10. We started initially with transaction traces, and all the transaction traces prior to APM 9.6 contained the information on method calls which we provided as part of our agent instrumentation. So you are APM specialists, you have seen the metrics in Investigator, metrics in the transaction trace, and exactly the same components were part of our transaction traces. Now with 9.6, we forwarded this whole information to get deeper visibility in transaction traces. And for this, I'd like to point out here these three axes: the visibility, then transaction triggering, and call path analysis. Now we have deep transaction information on error snapshots, transaction traces. By doing this, we take a look into the complexity of transactions, and we're using a specific scoring mechanism to identify what is important. I will talk on the next slides more about the complexity and the scoring and how we identify what are important components as a part of a transaction. Beyond 9.6, we have full integration into stalls functionality for deep transaction components, and we can provide different levels of visibility dependent on how deep you want to have information inside your transactions. I will talk about the trade-offs for deep visibility and these different levels for monitoring in a minute. In addition, we also support now error snapshots for deep visibility and the discovery of errors inside transactions. Going forward beyond APM 10, we have the new transaction entry points, which is part of our presentation today, to extend the visibility. Integration with differential analysis, it's a separate feature, but now differential analysis, our tool in APM 10 to identify anomalies in certain metrics, can trigger automated transaction trace, which also contain deep information. And this combined, we can provide now full visibility on transactions, errors, and stalls whenever a problem appears inside the application. So let's have a closer look into the functionality. Smart Instrumentation. For many years, we have method instrumentation with our bytecode in so-called PBD files. PBD files, probe builder directive files, are files which provide instructions at which methods to look at, which methods to instrument. As I mentioned before, there are many situations where we don't have components as a part of a non-stop monitoring, and we want deeper analysis. So the new functionality, Smart Instrumentation, which you can see in step 2, while the JVM is starting up, we now bytecode, analyze, and parse all the methods inside the engine. Looking into step 3, we provide a scoring mechanism on these different components. And on this scoring mechanism, we put a lot of logic, a lot of effort, best practices into it. And part of the scoring would be the method size, whether there are loops inside a method, whether a method is calling into a different package, whether we have different visibilities, means, for example, a public method is getting a different scoring than a private or a package declared method, or a package which has a name service calling into a package with a name entity would have a different scoring than a call inside one package, for example. So as you can see, for us, it was important to understand the application, to understand what are potential troublemakers, where is the complexity inside an application, inside a call stack, and where can we improve visibility with the scoring mechanism. given now every method has a different scoring. In step 4, we will evaluate this scoring with pre-configured scoring levels. And now inside the Infoscope agent profile, I will talk about this later as well in an example. You can choose between different scoring levels, and then we will decide from here whether we will show this information inside our transaction traces, error snapshots, stall snapshots, and the method in step 5 will be instrumented. On entry point detection, which is a very, very similar approach but solves a different type of complexity, we go a slightly different way. So what is entry point detection about? Let's say, like I pointed out in step 1, we do have visibility into a component which we would declare, for example, as a controller, but not as an inbound component like a servlet or a start of a transaction. And we only have a starting point in the middle. This could apply, for example, to transactions which run across multiple threads, applications which are not using, for example, HTTP, JMS traffic, or any common protocol. So automated entry point detection focuses on identifying the correct, the very first possible transaction start. There we have two possible entry points where this whole mechanism starts. The first one is, as I said, we have a component or a transaction with no entry point, for example, an EGB, or we have a transaction where we have a call to any type of communication, like, for example, a database communication, but out of the box, no visibility into that transaction. So in both ways, what we do is we take snapshots, and what you can see here in step 2, we do take snapshots of the transaction, and on these transactions, we analyze the whole call path, apply rules to each individual component, monitor them, and that's what you can see here in step 3, and instrument them and give them as a proposal as the best possible starting point for this transaction. In step 4, once this process happens, and this process doesn't happen instantly, so once you have the first requests done, this engine will work, take the snapshots, and will take some requests to identify the perfect entry component. Once done in step 4, this entry component will be instrumented, the right component chosen, and what I will show you in the next step, you will see it as a start of a transaction, as an automated entry point in transaction traces, and part of the investigator tree. So how are these transactions visualized? And what you can see here is our two visualizations for transaction traces. The one on the upper left is what we call upside-down wedding cake view, where you can see the components, the call stack, top-down, left to right. And I chose this example because you can see very well the difference between out-of-the-box detected components and what we call smart instrumented detailed components. And all the smart instrumentation components are here shown with this lightning bolt in the beginning, and I additionally mark them with a star. So the metrics which we have covered out of the box, they follow the metric tree structure, like web services server and then the URL and the web services process. On deep components, we show the whole package, class name, and method name invoked. In addition, you can see here the coloring, red bars and yellow bars. Red bars would indicate there was an exception inside this call stack, and you can see which of the transaction components, doesn't matter whether deep components or instrumented components, will are identified as problem areas. An important note, and as I discussed and explained on how we do deep instrumentation, this deep instrumentation, getting the right components, what you want to see, the most important potential troublemakers maybe, into the transaction traces. It's happening without limit. So whenever we identify instantly there was a problem on a component, you have this information already on the first request. Once a request has an exception, has a high response time, they are instantly provided with these information, the transaction traces. Very similar on the right side, you can see the tree view transaction trace visualization, now also with deep components, also indicated with a lightning bolt. So you can see deep components here, same way, combined where is the absolute time, where is the relative time spent on a transaction. There are different ways how we visualize components, and this one here is a visualization of error details, and that's a new feature which we also introduced as part of Smart Instrumentation. Now we can identify on every component, once there was an exception inside the system, we instantly mark that component for monitoring and report the transactions, the error message, all through the transaction snapshot. As an explanation for this example, you can read this transaction bottom up. So we can see on the bottom the class closable HTTP client execute through an exception that it can't connect to a certain host to a certain port. And this exception is now propagated the whole call stack into the business logic, and you can easily identify whenever there was a problem. And that's a huge difference and advantage compared to older Introscope versions where we looked only on dedicated methods for problems, for exceptions inside the code. Oops, I'm sorry, wrong button. The automated front-end detection now, in addition to transaction traces, participates on showing the information in the investigator tree. And that's a small difference. They are not showed, as you know it, on the front-end node. They are now shown as automatic entry points with class name and method name in the investigator tree. So the instrumentation and artifacts, most of the properties for instrumentation levels for smart instrumentation are hot properties. It means you don't need to restart for some of the features. For others, you do need to restart. One example, if you can choose between more visibility and less visibility, an important switch in the Introscope agent profile is the instrumentation level. You can choose between 3 different visibility levels, low, medium, and high, and this applies to the scoring. So dependent on the scores, we give every single method. This switch, low, medium, high, defines whether a method will be visible. And that depends on your use case. Maybe for production monitoring, you're focusing on a certain granularity level, and when you work on QA or in dev environments, you might be interested into a higher visibility. There are multiple options, configurations in the Introscope agent profile. You can go through, you can skip packages for Smart Instrumentation packages you're not interested in seeing, or in addition, once you know there is a package which I want to give a special focus to look into, you can also declare it on the Smart Instrumentation feature inside the Introscope agent profile to give it a higher scope to look into it and see it definitely in Smart Traces. Why do we have these different 3 levels, low, medium, high? Yeah, visibility comes with some kind of costs when we gather the collection, and it also affects the readability of transaction traces. So again, when you want to have deep analysis, maybe with a slightly heavier instrumentation, you want to go for high, but it can happen that our transaction traces are really getting huge and more difficult to read, to browse through. So if you want to focus more on the essential and some deeper components, maybe components we've not covered, I would recommend low or medium. For dev environments, for deep code analysis, or special applications like batch applications, a lot of custom code, I would recommend the high level here. And it goes even one step further on the automated entry point detection, because we are now producing an artifact which you can reuse and reconfigure. And that's a completely new functionality. Once you run the automated entry point detection, inside the agent, inside the core config hot deploy folder, a new file, autopersist.pbd, will be created. And inside this autopersist.pbd, you will see as instrumentation instructions the information which we gathered, and you can extract this data, copy-paste them even into a new PBD file, put a front-end marker on it, and create your own naming, your own instrumentation with it. Here an example of my autopersist PBD, and there are many different entries. Let's focus on the one with the red square, and this is auto-generated. So trace1 method of class is the instruction that we now want to have a look into the class, for example, network output channel, into the flush method. The tracer for automatically created is the autopersist tracer, and the metric path is automatic entry points class name method. These are the instructions to create the new component in the metric tree. Now, once you've reviewed our results from the automated front-end detection, you have a special type of application you want to get visibility in. You can copy-paste this line into your own PBD file, and that would be a lot bigger topic, how to work with PBD files. But as an example, and I know many of you already work on your own PBD files, you can replace the autopersist tracer with a front-end marker or plain point tracer, create your own metric path, and this way you created your own new front-end, your own new transaction entry point. So this was the overview and some details, some background on Smart Instrumentation, on dynamic instrumentation, how to use it, when to use it, what you can do with this. And I think we exactly at time for our 30-minute session. It would be also now a good time, in case you have questions, we can straight answer them on our call.
At this time, if you would like to ask a question, please press *1 on your telephone keypad. And we do have a question from the line of Jose Marquez. Jose, your line is opened.
Okay, I'm sorry. In the trace view slide that you presented, how does APM indicate the lightning bolt view? I'm using APM 10.1 with Smart Instrumentation. I've never seen that before.
Yes, so this lightning bolt you can see in the web view, and whenever you have this package and method name, class name, so whenever you have this component, it's exactly visualized this way. Do you mostly work on the workstation or on the web view?
Yes, that's why. So this only works in web view?
Yes, so the components are shown in both UIs, but the lightning bolt only appears on the web view.
I understand. Okay, thank you.
Welcome. Thank you.
And as a reminder, to ask a question, please press *1 on your telephone keypad. And there are no further questions at this time.
Andreas, we did have one more question come into the chat from Fred K. He asks, does the front-end tracers also show up as applications in the ETC?
Okay, yes, and a very good question, thank you. I'd like to differentiate here between APM 10 and 10.1. As you know, again, this is a very, very big topic we can also discuss separately. In short, APM 10 got the Team Center instructions from the agent. APM 10.1 is building the Team Center nodes by analyzing transaction traces. So the very short answer to your question, in APM 10.0, no, it won't appear in Team Center. In APM 10.1, yes. As soon as you have put a front-end marker on your own entry point component, it will automatically show up as a node on Team Center.
Okay, and that was it for our questions that came into the chat.
And as a reminder, to ask an audio question, please press *1 on your telephone keypad. And there are no audio questions at this time.
Okay. Well, thank you so much, Andreas. That was a really great presentation. Thank you, everyone, so much for joining. There is a poll that will appear on the side of your screen to please rate the effectiveness of today's webcast topic. If you could give us a vote, that would be great. We really love your feedback on how we're doing as far as webcast topics and stuff that we'd like to put out in the future. Thank you once again for joining. Have a great week, and we'll see you in the next APM webcast. Thank you.
This concludes today's conference call. You may now disconnect.